Welcome to the Cape Computer Science Unit 1 IA walkthrough. This video is part of a series of 7 videos, I think, that will give you a full start to finish walkthrough of what the Computer Science Unit 1 IA is supposed to look like, giving you examples, working out the code, showing you the documentation, and giving you all the little tips and tricks in between about how you should approach your IA. So I hope you learned something, but just remember, I'm not a teacher. Whatever your teacher decides to tell you to do, follow what your teacher says. This is for people who don't have teachers, if your teacher's sick, or you're doing it on your own, right? So, enjoy! Alright, so welcome to video number 2. We are going through the Computer Science Unit 1 IA. Basically, we're trying to go through our whole Computer Science IA from Unit 1 to Unit 2, but this is the Unit 1 part. So far we've gone through the syllabus. I went through the layout of your table of contents, how you had to put everything as heading 1 and whatnot. And then we went through the example of our problem definition, and I gave you a sample one here, and it looks something like this. That will kind of help you understand what needs to be done. The next thing that we have to go to, according to the syllabus and the mark scheme that actually starts giving you marks, would be the functional requirements. So the identification of specifications, there's 4 marks, there's functional requirements and non-functional requirements. Now, I could have put individual headings for identification of specifications in here and then put non-functional and functional, but I put them separately because I think that when you put them separately, it kind of gives you a bigger feel of how important functional requirements and non-functional requirements are used. Now, your teacher might require you to put the headings exactly as they have it here. That's okay, that's cool. If your teacher requires that, no problem. If you don't, then it's okay. Once the examiner can see that you have your marks ready and well laid out, you should be okay. So, functional requirements. So let's go. From my problem definition, I basically said that the hospital is kind of in a mess with collecting data. And essentially what you're doing most of the times when you're doing your comp sci IA is you're doing a database. But you're using data structures to hold that data. So for your functional requirements, these are the things that the program must deliver in order to solve the problem. Functional requirements are things that people usually see most of the time. So it should mirror the functions that you have, that you'll put in the program. Basically, whatever the menu lists would be a functional requirement because the functionality of the program is based on that. So it's recommended you have about 5 depending on the problem being solved. I think that you should go up to about 7. But the functional requirements is only 2 marks. Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of the IA, or you just need somewhere to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. I don't know what they're exactly looking for, but I know for sure, here's what they like to look for. Add, remove, update, search, for sure. Alright, once you can get those 4, add, remove, update, search, you're in the game. There's not an examiner that will see those 4 and be like, nah boy, this child can't get any marks. The other functions you add in between there could be anything. It could be a function to, well, definitely have a function to display the menu. You could have a function to print to a file. You could have a function to read from a file. You could have a function to print to the screen. You could have a function that could display a welcome. All those things add up to like all the functions that you should have, because your whole program should have at least 5 functions according to the breakdown. Let me see. Structure, because the composition of functions, overall program comprises the functions as independent units. That's 5 to 6 marks, right? So they're usually looking for like about 6 to 7, but they're not checking to see if you have actually 5 to 7 functions. They're checking to see if you have 5 to 7 functions that make sense. So you can't just put 5 functions that just add up things. That'll be kind of weird. What they want you to do is they want you to make sense about how your program is like decomposed into smaller parts. So let's just focus on the functional requirements part for now, right? So our problem here is that there are problems with collecting patient data. So we definitely want to be able to functional requirement number 1, you put them in bullet points because bullet points will make your life a whole lot easier. if you go with bullet points. So you'll be able to like add a patient to the database. Add a patient to the hospital database. Remove a patient from the database. Update a patient record. Search for a patient. Print a record to the screen, and then print certain records to output files. Right. So in order to make this solution easier to understand, what we want to do is we want to be able to add a patient. Of course, you must be able to add a patient. You must be able to remove a patient from the database. You must be able to update a patient, let's say their number changed, their name changes, something like that. You should be able to search for a patient. You should be able to print the record to the screen, and you should be able to output the files. Now, updating a patient record is a little, in terms of code, it's a little technical because you have to fill out an array and then you have to jump the array back by one. Oh no, you have to find the location and then update the values inside there. Removing a patient is one of the difficult ones because you have to remove that particular record and shift everything down from there. So usually the remove one, this one is a little tough to do based on your knowledge in Unit 1. In Unit 2, your knowledge of it gets a little better because if you just sort over the records, it will sort it back automatically and you don't have to do the remove. But when you don't learn searches and sorts in Unit 1. If you learn searches and sorts in Unit 1, then removing a patient is fairly easy because you just have to remove the patient and then call back the sort and it'll sort it over because the patient has been removed. But because you don't know how to sort, you're going to have to do a particular shift kind of code thing. But it's okay, there's no problem. But these here are good functional requirements because it shows that from your problem definition, these are the functions that you need to have in order for your program to work according to the problem that you have. So after you go through your functional requirements, you can add functional requirements from time to time. Actually, you don't really add functional requirements. The functional requirements come straight from the problem definition and you take that and roll with it. Non-functional requirements now, these are the things that sometimes you have to add to because you realize that you need to do certain things in the background to get some of the functions to work. So non-functional requirements, these are the things that tend to happen in the background but are necessary to achieve functionality. They tend to deal with the data structures used, access methods, data manipulation, data entry, error handling. So it's a lot more developer focus and it sees things basically from the back end of the problem. You're thinking, okay, in the back end of this problem, what is actually happening? What do I have to do? Most people don't ever see what you have to do in the functional requirement, non-functional requirements because that's for you to figure out. Functional stuff, people will see in front, right? So we want to say, okay, we want to be able to store the data in an organized fashion so it'll be easy to retrieve. That means use a proper data structure. Search the data quickly means use a search. Display errors when the error is entered incorrectly. Read from files to appropriate data structures. The security of the system should have a login password. You should have clarity of the menu on display, and you should have the capacity to hold many records. Okay, that's good. That is quite all right there. So I didn't need to add anything because non-functional requirements, these are things that could go across the board for any problem. For most problems, you want to be able to do all of these things. But then there are certain things, certain problems that you might be trying to solve where you need to have a login password, where you need to have like a welcome screen or some kind of thing like that. So I'll just take out the we'll use this as the example here, and I'll just put in some that I think will be necessary inside here. So let's start with the non-functional requirements, and I'll start with store the patient data in an appropriate data structure for easy manipulation. Right, appropriate, right. And I'm just taking the generic terms and being able to match it to the actual problem, right? So then I'll say search for a patient by patient ID easily. Display errors to the user when a patient ID doesn't exist. Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of the IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. Right. So once I have these two functional requirements and non-functional requirements, these are going to be my guide when it comes to coding, meaning I have to achieve all of these things in the process of building the program. There are some cases where you bounce up an issue in the code where you realize, nah boy, this function too hard to implement and it's taking too long. You just come back to the functional requirements and tick it off, right? The good thing is once you have extra, once you have more, the marks will be allocated to you. So if we look at the mark scheme, functional requirements are 2 marks and non-functional is 2 marks. Now, they have all functional requirements identified and all non-functional requirements identified. It's very hard to say what all the functional requirements or all the non-functional requirements are in a particular IA that you make up for yourself. So the examiner has to look at your IA that you're trying to do and make sense of it and be like, okay, I think that's all that you should have. When they have most non-functional requirements or 50%, I don't know how they're going to figure out what most is because there's usually a number that they have to look for. So I'm thinking that they're looking for about 5 to 6. And if you have like 3, you'll get 1 mark. And if you have all 6 or 5 and 6, you'll get the next mark. I'm thinking that's what they will do. But I can't say for sure because it's a human being marking it. And of course it has to match back to what you said in your problem definition. So think a little bit, look at your problem definition and see if your functional requirements are solving this second paragraph. The second paragraph is usually where most of your issues are. If you could look at all the issues there and see that they have, they're solving most of the problems, then you could tell yourself, all right, I am solving most of the issues that the people could have, right? So from there, you move on to your narrative. Now your narrative should follow along with what your functional requirements are going to do and kind of explain what the program is going to do. But you must put in little technical terms. There is no mark, 0, not a mark for the word narrative in the IA. It used to have marks, but they took it out. So the narrative not carrying any marks, but the narrative is going to help you think through the process of what your code is going to do. So let's see what the narrative says. So the narrative should be a paragraph style explanation of what the program should do. Of course it's narrative, so it's writing. You gotta think of it like explaining it to a non-technical person and breaking down what should take place when the user uses the program. You don't use as much technical language, but ensure that the functions that are going to be used are well laid out. Use of bullet points and paragraphs may help. In the end, someone should be able to read through the narrative and understand what the end product should produce. Now, the narrative, I think what they did is in the IA, they put documentation at the bottom. Where the documentation, technical documentation and user documentation, this kind of like takes the place of the narrative. I think that's what they intended to do. So instead of putting narrative and giving marks with the user documentation, should sound narrative-ish. But this narrative here, the whole point of narrative is so it should be easy to follow for a non-technical person, but you still have some technical terms inside. So somebody who's semi-technical should be able to follow your narrative. So let's try to hit the narrative and see what we come up with here, right? So we want to say Why is it saying heading 1? I don't want heading 1. I don't want it to be that kind. Right. Okay, so we want to start off by saying when the user opens the program, they should be greeted with a welcome screen that thanks them for using the no, not thanks them. That shows them the name of the hospital and yeah, that shows them the name of the hospital. They should then be greeted, given a menu with, no, they should be given a password prompt that allows them to enter the password for the system. Upon successful entry of the password, they should be given the menu options as follows. All right, so this will now give you like a little intro into what's supposed to happen. I noticed we're describing what the program is supposed to do, but we're not describing what the program is going to look like or whatnot. We're just going to follow along like this. So it'll be given many options as follows, and you hit them the bullet points. You'll be like add a patient, remove a patient. Let me put remove last. Add a patient, update a patient, search for a patient, remove a patient, print patient records, print patient record to a file. So once we have the narrative sort of laid out and we kind of tell them what the menu is going to do, we want to say we're going to print the patient record to a file. No, let's not print patient record. Let's say print patient record to the screen. Then we want to put print critical patients to a file, right? So we want to print a list of critical patients. Print a list of critical patients to a file. That'll be a nice functionality to have because the hospital and knowing the critical patients just makes sense, right? I think, yeah. So what we have now is, right, so we have a basic breakdown of the list of things that we want to do. And to exit, press press 0, right? Okay, right. So then we want to see now each of the functions will perform the assigned task and then display the menu. Again, the user can perform as many functions as possible before choosing 0 to exit. Right, the only problem is I haven't mentioned anything about the file. So let's do that. Upon successful entry of the password, the program will read the patient data file and then display the menu. Then, yeah, so we have to see that it will read the patient data file, then display the menu. Program will read the patient data file, then display the menu options as follows. Pressing 0 to exit. Upon exiting, the patient data file will be updated so that the next time the program is opened, the updates would have been registered in the patient info file, right? So I'm going to, when I finish this whole thing, I'm going to give you a minimal breakdown of things that you could do to get the bare minimum of marks, but that's risky. I don't always like to let students do the bare minimum, because if you make a mistake with the bare minimum, you lose marks. So I always go for a little extra. The reason you go for a little extra is because you give yourself some wiggle room. If you make a mistake, you still have something to fall back on. So some of the things I have here, they are a little bit extra, but they make sense within the context of the program, and that's one. And two, remember, you're fighting for marks. So when you're fighting for marks, you want to make sure that you give yourself the best possible shot, right? So we have so far the narrative. So I went through in this video, I went through the functional requirements, the non-functional requirements, and you could see how the functional requirements flow into the narrative. And the non-functional requirements, well, we don't really have to do anything with that yet until we reach the pseudocode and the code, because in the non-functional requirements, we have to go through all of these different things. And this is where you're going to have the choosing of your file, the file structure, the layout, and all that stuff. That's where you want to put some effort into. So I think that's the end of yeah, that'll be the end of this video. So what we'll do is, after non-functional requirements, next a narrative, functional and non-functional narrative. Next video, we're going to tackle the pseudocode. And we're going to break down how the pseudocode is going to look. And I'm going to show you how sometimes the way you lay out the pseudocode could make it easier for you when you have to actually code. Sometimes you might reverse engineer it and code it instead, and then go to the pseudocode. But I'm going to go the traditional way and show you how, when you do the pseudocode, you can lay it out logically, so that when it's time to code, all you have to do is convert those things to code. But when we get to the code part, I will also show you how, when you do the code, you could reverse engineer your code to make it into pseudocode, because some students find it easier to just write out the code one time, go through the process of making the mistakes and getting things done, and then turn it to pseudocode after. Some students prefer to lay out their pseudocode clearly, logically, because they understand everything that's happening, and then write the code. So pseudocode should be the next video, and we will focus on getting those marks there, right? So of course, if you haven't downloaded the app, go to makeITsimpleTT.com/learn it, or you could search in the App Store or the Play Store and look for Learn It by makeITsimpleTT. All these videos will be laid out in chronological order. Plus, they'll have past paper questions and answers. You'll probably have some PDFs that will help you do different things, and just all general stuff that will help you in your computer science journey. You might have some theory inside there too. So that app was made specifically just to help IT and computer science C6 students, and it has a lot of content. So you can check that out. We'll be back for the next video, which is pseudocode. Should be video number 3, I think. I think it should be, yeah, that'll be about this video, right? So we'll be back after I go and drink some water. Yeah. Or maybe I might do the next video tomorrow. Who knows? The hoodie might change. I don't know. Let's see.